Wow, that's really blurry. Come on, focus. There we go. All right, so the vector addition questions, I think we were on number 2 when we ran out of time. So number 2, you are walking south. I think we had almost finished this one. 30 meters south, and then 30 meters east. And the question wanted you to draw a diagram showing this and find the resulting displacement. So the resulting displacement is going to be right here. Oh, I think we had actually almost finished it because she told me the angle, I believe. So you're going to do the Pythagorean theorem, square them, add them together, take the square root, and when you do that, you get, is it 509.9 maybe, kilometers. But then we also need the angle. So the angle's always up here at the origin where you started. So this is going to be theta. And some of you right away recognize that it's going to be 45 degrees because this is an isosceles right triangle. The two legs are the same. This is 90. And so the two angles opposite the legs have to be equal. If you don't recognize it as that, don't stress. Just do tan theta is equal to 30 meters over 30 meters, which is tan theta is equal to 1. Do the inverse tan and get 45 degrees. Okay? Now, we need to write it as a square bracket. 45 is going to be here in the center. And like if you said to me, turn at an angle of 45 degrees, you have to tell me where to start. And so we always use as our starting point north, south, east, or west. So we take a look, well, we're measuring off the south. So south goes first. And then you're turning east. So it's from the south, turn 45 degrees east. Okay? So this would be the answer to number 2. Find the resulting displacement. Yes, I just thought I should read the question to make sure that I wasn't making it up. Number 3. In number 3, a ship leaves a home port expecting to travel 500 kilometers due south. Before it can move, a severe storm comes up and blows it due east. Okay, so this ship is here, and it wants to go 500 kilometers south to a port down here. Okay? But before it can do that, the wind blows it 100 kilometers east. So now it doesn't want to have to go like back and then down. So now the question wants to know how far is the ship from its destination now? So it's here. I just imagine those lines hit. Okay? And you can find this. It's going to be 500 kilometers squared plus 100 kilometers squared, and then of course take the square root. Oh, and that's what this was. I did the answer. Oh, man, such an idiot. I did the answer to the second one, the third one up here when I looked over, because obviously 30 squared and 30 squared is not 500. 900, 1800, take the square root, 42.43. Sorry about that. If I had written the numbers down, I would have caught myself. All right. Down here, though, the answer is 509.9 kilometers. Okay, but again, you need the angle. So it needs to be this angle. This time you probably can't maybe figure it out in your head. So again, use tan theta is equal to the opposite 500 kilometers over 100 kilometers. So inverse tan of 5, and you should get, somewhere I have a calculator, but I can't reach it. And I'm going to have to reach it because I don't know that I can do inverse tan of 5 in my head. 78 point something? 78.69. Okay, so the angle is going to be 78.69 degrees. Which way are we measuring off of? Well, this guy was going east, but now to get to your destination, it would have to be west, right? You'd have to turn around. So you'd be measuring off the west and then going down, that would be south. So this is where he is from his destination. And then the question says, what direction must he travel? And that's what we just did, west 78 degrees south. Okay, so that's number 3. Sorry about that 42.43 up there. Never pays to just look at the answer you have in your notes, especially when you're not looking at the right question. Number 4. Number 4 is actually not bad if you draw it carefully. Okay, so start somewhere here, and Buddy goes 4 kilometers east. So draw it in. And then he turns and he goes 6 kilometers south. So now your 6 kilometers south should be longer than your 4 kilometers east when you draw your vector, because 6 is bigger than 4. Then he turns again and he goes 3 kilometers east. So it should be a bit shorter than your 4, about half as long as your 6. Then he turns and he goes 5 kilometers north, so not quite all the way back up. 5 kilometers north. And now he turns and goes 10, that's 7, kilometers west. Imagine that's on a straight line. After the 10 kilometers west, he now goes 8 north. 8 kilometers north, and then he turns and he comes back 3 kilometers. Okay? And so then the question says, after 3 days in the above journey, the hiker is lost. I guess the compass didn't really do him much good. Compute the drawing a diagram, compute the hiker's displacement from the camp. His displacement from where he starts to where he ends. His displacement is going to be, imagine that those two tips hit, is going to be right there. Okay? And really, this vector, like all vectors, is a hypotenuse of a right angle triangle. You could draw in its legs. They would be here and here, always head to tail. Every hypotenuse is actually every vector is a hypotenuse of a right angle triangle, actually always searching for its legs. You might even hear it haunt you saying, help me find my legs, help me find my legs. And we can if we look at our diagram. How long must this piece be? Well, he went 4 east, and then another 3 east, that's 7 east, and then he went 10 west. So 7 east and 10 west, remember when they're in opposite direction, subtract and keep the direction of the bigger. In the north-south part, how big is this piece? Well, he went 6 south and then 5 north. So that leaves us with 1 south. Then he went 8 north, so that should leave us with 7 north. Then he went 3 south, so that should leave us with 4 kilometers north. Okay, so one leg is 3 kilometers, the other leg is 4 kilometers. You now have a right angle triangle. Square them, add them together, take the square root. It's a 3, 4, 5 for those of you who know what that is. So 3 squared plus 4 squared, 16 plus 9, 25. Take the square root 5. But of course we need the angle. It's right here. So you would do inverse tan of 4 kilometers over 3 kilometers. And that one I can do in my head. It's 53.13 degrees. So you would write square bracket. And here is going to be 53.13 degrees. Which way are we measuring off of? West. Which way did he turn? North. This is the answer to the first part of the question. The second part says, what direction should be taken to get back to the camp? So to get back to the camp, he wants to go this way, right? He doesn't want to follow his footsteps and all those kilometers. So this angle up here and this angle that you just found are the same. That's alternate interior angles, which you may have learned somewhere in math, right? When you have 2 parallel lines, the angles on a transversal that cuts them, these 2 angles are the same. So it's the angle is going to be 53.13. You're measuring this time from the east, and you're turning south. And so the answer is just the opposite. to what the direction he was in. Okay? All right.